Okay, so these are the notes for section 2.5. So we're going to be using our textbook again here for a little while. And what we're going to do today is kind of follow up with what we did, last week, which was solving one-step equations with addition and subtraction. But now we're going to solve one-step equations with multiplication and division. Okay, so multiplication and division are inverse operations. That means they undo each other, just like addition and subtraction undo each other. So we're going to use multiplication to undo division and division to undo multiplication when we solve equations. And remember to keep everything balanced and do the same thing to both sides of the equal sign. Okay, so here's the first one, 6m equals 30. So this, when it's written this way, this is multiplication. There's no adding, subtracting signs in there. It's just a number right next to the variable. Whenever you see that, that's multiplication. So this says 6 times some number m is 30. Most of you can do that in your head and tell me the answer is 5. But this is how I want you to show your steps when you're doing it. Okay, so 6m is 30. 6 times m is 30 is what's going on here. So to undo multiplication, we divide. So when we do division, we draw a fraction line like that and put the number in front of the variable underneath it because we're going to divide both sides here by 6 to make that 6 cancel out and clear off. So I get m equals 30 divided by 6, which is 5. Okay, 6 over 6 is 1, so what we're left with is 1m. So we're going to divide both sides by the number in front of the variable. Doesn't matter if it's a negative like this one. I got negative 4x is 32. Well, I'm going to clear out that negative 4 by dividing by negative 4. Just like that. Okay, and I get x equals 32 divided by negative 4 is negative 8. Okay, so again, when it's multiplication, it's just going to be written like this. There won't be an x in there. That would be confusing, especially with x's as variables. It's just going to be the number right in front of the variable, just stuck together. So that's going to be multiplication. This one, sorry, that's a 7, is division. And division is not going to be written with a division sign. It's going to be written like a fraction. So n over 7 equals 3. So some number divided by 7 is 3. Again, a lot of you could probably figure out that the answer is 21, but this is how we're going to show our steps. So to undo dividing by 7, what I'm going to do is I'm going to multiply both sides by 7, and I'm going to just write it in parentheses like that on both sides. So here, 7 over 7, if I were to swing that 7 underneath that one, you'll see that's just 1. 7 over 7 is 1. So those 7s basically cancel each other out, and you get n equals 3 times 7, or 21. Again, just like up here, it doesn't matter if it's a negative. So a, that's an a, not a 9. A divided by negative 4 is 7. So we're going to clear out the dividing by negative 4 by multiplying both sides by negative 4. Again, over here, negative 4 over 4, they cancel each other out. And all you're left with is a equal to negative 28. Okay, so that's a little hard to read. That's a 2. Negative 28. Okay, so here's multiplication. You got the number right in front of the variable like that. 6 times m is 30. So to undo that and to solve that, we divide both sides by 6. Here's an equation with division in it. It's written kind of like a fraction. Again, no division symbol. You may see that, but rarely, hardly ever as far as I can tell in this class. So n over 7, or n divided by 7, is 3. So to get rid of dividing by 7, we multiplied by 7. So dividing undoes multiplication, multiplying undoes dividing to get that variable all by itself at the end. Okay, one more thing. And these are going to look a little tricky, but they're not so bad. These have a fraction in it. Oh boy, look at that. Well, it's easy to clear away a fraction. All you got to do is multiply by its reciprocal and everything will cancel out. So when you have a fraction in front of the variable, see we're multiplying by a fraction. So to clear that out, what we're going to do is multiply by its reciprocal. It's really the same thing as dividing by a fraction, if you'll remember that division by a fraction is multiplying by its reciprocal. But I like to just think of it as canceling out. So to make this fraction go away, I'm going to times both sides by its reciprocal. So flip it over. Same thing over here. Okay, and it may help to put a 1 underneath the 10 when you multiply them. And if you can, do some canceling over here too. So here, look, 2 goes away, 5 goes away, all you're left with is an x. Again, everything cancels out. Now this side, again, you can time straight across, you get 50 over 2, which is 25. I'm going to do a little canceling here. See, 2 goes into 2 once, and 2 goes into 10 5 times. So I end up with 5 times 5, which is 25. Now I think in your textbook most of the problems are set up so that you can do some canceling like this. Okay, here's another one. So 9 equals negative 3/7 m. Again, it has doesn't matter at all if it's a negative. We're going to do the same thing, and I'm just going to write it over here. I'm going to times by the reciprocal. If it's a negative fraction, make your reciprocal -2. To make a negative, oops, I said the word 2 and wrote the number 2. Because a negative times a negative is a positive. What I really wanted to write on the bottom was a 3, but my brain tricked me a little bit there. Okay? And do the same thing on this side. Okay, again, if it helps to put a 1 under there, go for it. So you'll notice here, again, the 7's go away, the 3's go away, and a negative times a negative is a positive. So all we're left with is our variable, m. Okay, so m equals, and over here, again, same thing, I could time straight across, but I don't like doing that because I'd have to reduce it at the end. But notice here, 3 goes into 9 3 times, so I'm going to make that a 1 and that a 3. And this side just becomes negative 7 times 3, which is, oops, wrong pen, negative 21. Okay, so if you have a fraction in front of the variable, times both sides by its reciprocal or the fraction flipped over. Cancel out what you can on the other side here. Everything's going to cancel out on the side with the variable, and save yourself a little work so you don't have to reduce it at the end. Okay, well that should hopefully get you through all of the problems on section 2.5, and please let me know if you have any questions. Thank you.